This question is about cells. Half equations for two electrodes that combine to make a non-rechargeable cell are shown. Identify the oxidizing agent. So this is seeing if you remember that an oxidizing agent is the species that accepts electrons. The species that accepts electrons is found on the left-hand side of the more positive of the two. So the more positive electrode potential is plus 0.52. The species in there that is changing oxidation states to accept electrons, you can see that the Mn is plus 4 here and plus 3 there, so that's accepting. If we were to look at the nitrogen, which we might think of as changing oxidation state, it's actually minus 3 in both. So it's the MnO2 that's the oxidizing agent. Cross-section through the silver rechargeable zinc rechargeable cell is shown. Suggests the function of the porous separator. The porous separator acts as a salt bridge, and we know that the purpose of a salt bridge is to allow transfer of ions. From one half cell to the other. Standard electrode potentials for two half equations are shown. Give the overall equation when it's recharging. So this is not when it's discharging. So normally when it would be discharging, the most positive would get to go the way it's written and the negative backwards. But we're recharging, so we want the negative one to go forwards and the positive one to go backwards. So we're combining these two. So I'm actually going to rewrite the one that needs to go backwards just underneath. They've both got 2 electrons, so the 2 electrons are going to cancel. They've got 2 OH minuses that are going to cancel. And we've got a water that's going to cancel. So we've got ZNO plus 2Ag goes to Ag2O plus Zn. And just have a quick double check that this equation that you've come up with actually balances. And if it does, it's probably looking good. The EMF of the alkaline hydrogen oxygen fuel cell is 1.23 volts. The standard electrode potential for one of the electrodes in the alkaline hydrogen oxygen fuel cell is shown. Give the half equation for the other. So remember that the hydrogen oxygen fuel cell is where hydrogen and oxygen create water. So if we were to balance that equation out, we need to do that. So when we add up our two half equations, that's what they've got to give. So you may well want to work this out from sort of subtracting the equation that you've got from the overall equation, or you may have just remembered it. If you've just remembered it, that's great. If you're subtracting it from what you've got, you would need to sort of have a look. It's going to need to have, in order to balance out, it's going to have electrons, and we're trying to do, this is the negative half cell, because it's a negative value, so we're trying to do the positive one. So the negative one's going to go backwards. So this is quite hard to do in one step, working it out. This one's going to go backwards. So maybe it might help if we just shift this all up. So remember, our overall equation looks like this. The negative half cell is going to go backwards, so this would be like this. Now, it looks like in order to get the hydrogens to be the same, because remember that when we combine our second half equation that we don't know, we're trying to aim to get this. So I'm going to double everything up so that I would end up with the same amount of hydrogen. Kind of means my second equation is going to have 4 electrons on this side. the hydrogens are going to cancel. I'm going to need 4 OH minuses on this side because there's no OH minuses in the overall equation. We can see that the overall equation has 2 waters. At the moment we've got 4. So we're going to need 2 waters on the left hand side so that the 2 of the 4 waters cancel out, and an oxygen because we need to provide the oxygen for the overall equation. So you can just about work it out, but I would say that possibly learning the alkaline fuel cell equations might be simpler. This set of equations and the equations for the lithium ion battery are worth learning. The sum though we can definitely do. 1.23 equals the positive half cell minus the negative half cell. So we need to work out what value minus 0.83. So we're going to do 1.23 minus 0.83 because remember minus would become, if I get minus would become plus. And so when I subtract it from the other side, that's going to give me the value of X, 0.40 volts. Suggests why the EMF values of the acidic and the alkaline hydrogen oxygen fuel cells are the same. Well, what we have to remember is that whether we do this in acidic conditions with H pluses or in alkaline like we've done above with OH minuses, we are aiming for the same overall fuel cell equation. And so we would have the same EMF. We've got the same equation that we wrote at the top, where 2 H pluses plus O2 make 2 H2Os.